Okay, Wildcats. Today we're looking at Friday, March 2nd, multiply and divide rational expressions on page 62. Now, there will not be a video for Monday, March 5th, because that's going to be the day we're going to practice adding, subtracting, multiplying, and dividing rational expressions. All right, so if you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at the notes. All right, multiply and divide rational expressions on page 62. Multiply rational expression steps. Step 1, factor the numerator and denominator. Step 2, cancel factors. And I would say actually changing cancel factors. Divide factors to become 1. Divide rational expression steps. Step 1, rewrite as a multiplication by the reciprocal. Step 2, factor the numerator and denominator. Step 3, cancel factors. And again, rewrite that as divide factors to become 1. Okay, with that, you would finish your notes. All right, now your notes are completed. Now let's take a look at the examples. All right, multiply and divide rational expressions. Simplify the following expressions. Example 1, 3 times 10 times 5 divided by 6. Okay, now we're going to write that in a little bit forward because remember, the multiplication property says that 10 times 6 is the same as 6 times 10. So, and 3 times 5 is the same as 5 times 3. So I'm going to rewrite this as 3 divided by 6 times 5 divided by 10. And we can do that because of the multiplication property, okay? And the reason we do that is because 3 divided by 6 reduces to become 1 half, and 5 divided by 10 reduces to be 1 half. So then 1 times 1 is 1, and 2 times 2 is 4. And that is simplified. Okay, example 2. So when dividing rational expressions, we first, and it says rewrite as multiplication by reciprocal. An easy way to remember that is you flip and multiply. So 3 divided by 2 divided by negative 9/16 becomes 3 divided by 2 times 16 divided by negative 9. And we're going to rewrite this as 16 divided by 2 times 3 divided by negative 9. And the reason we do that is because 16 divided by 2 becomes 8. And then 3 divided by negative 9 becomes 1 divided by negative 3. So 8 times 1 is 8. And then that's just 1. 16 divided by 2 becomes 8 divided by 1. And 1 times negative 3 is negative 3. All right, example 3. So again, we flip and multiply so that 2 divided by 9 divided by 1/12 becomes 2 divided by 9 times 12 divided by 1. Well, that equals 2 times 12 is 24 divided by 9. Now, some little magic math here is you can simplify this if you understand that 8 times 3 is 24, and 3 times 3 is 9. And the reason we do that is because now we have this special 1. 3 divided by 3 is 1. So this is simplified as 8/3. All right, so now let's take a look at example 4. Now, I know your first instinct is to multiply 2 times 15 to get 30, but we're not going to do that. I'll show you why as we go through here. Okay, but we're going to rewrite this as 2 times 15. Then we're going to expand the x's and the y. So x to the fourth and x to the second power is a total of 6 x's. So that's 1, 2, 3, 4, 5, 6. And then y squared is 5y. So 1, 2, 3, 4, 5 divided by. Now we're going to, instead of writing 3 times 8, we're going to write it as 8 times 3. And then x squared and x cubed, that's 5x's. So 1, 2, 3, 4, 5. Notice I'm taking and making sure that the x's are lined up. Okay? Same with the y. So y squared is y times 2y's. Okay? Well, the reason we did this is because 2a reduces to be 1/4. And then 15 divided by 3 is 5 divided by 1. So now 1 times 5 is 5. And then that's actually 5 divided by 1. So 4 times 1 is 4. Now, anything divided by itself is 1. So this is 1, 1, 1, 1, 1. So you're left with an x. And then 1, 1. You're left with 3y. So that's y cubed. All right, example 5. All right, so whenever you divide fractions, you flip and multiply. So this becomes 4x cubed divided by 9x squared y times 9y to the fifth power divided by 16. Okay, at this point, again, we can write 4 times 9 is 9 times 4. So 9 times 4, and we're going to expand the x's. So that's 1, 2, 3 x's and 5y. So 1, 2, 3, 4, 5. The reason we did 9 times 4 is because now we have 9 times 16. There's 2 x's and then 1 y. Okay, well, 9 divided by 9 is 1. 4/16 reduces to be 1/4. X divided by x is 1, 1. Y divided by is 1. So we now have 1/4 x y to the 1, 2, 3, 4th power. All right, so now let's take a look at example 6. All right, so the key to these problems is you want to divide out common factors, okay? So here we're going to write this as x plus 2 times x plus 4. And we're going to factor because we want to see if we can divide anything out, okay? Well, we can factor out a 3 here, so that becomes 3 times x plus 4. And then this is the difference of squares, so that's factored to be x minus 2x plus 2. Okay, which equals x plus 2x plus 4. Now we're going to reorder this so we can divide things out. We can't do anything with the 3. I'm going to go ahead and put a 1 in front of there. Now there's an x plus 2. And I'm going to mark it out so I don't actually use it again. And then x plus 4. I'm marking it out. And then x minus 2. which anything divided by itself is 1, so this becomes 1, this becomes 1. So we're left with 1 divided by 3 times x minus 2. All right, let's take a look at example 7. All right, now again, whenever you divide fractions, you flip and multiply. So this is x, and I think this problem is quite long, so we're going to actually use as much space as we can. So I'm going to actually use space here first. So this becomes x to the 5th minus 4x cubed divided by x squared minus 1x minus 2 times x squared minus 1 divided by x to the 5th minus x to the 4th minus 2x cubed. All right, at this point, we're going to factor everything that we can, okay? So we can factor in x cubed from these two terms, so that's x cubed, which leaves x squared minus 4. And then x squared minus 1 is the difference of squares, so that's x minus 1 times x plus 1. And then this factors to become x and x. Now we know the only combination that makes negative 2 is 1 and negative 2. So that's going to be x plus 1, x minus 2. And we know this works because negative 2 plus 1 is a negative 1. Okay? Times, oh, actually, no, we're already times, I'm sorry. We've already timed right there. So then we factor here. So we can factor out an x cubed from those terms. So x cubed, which leaves x squared minus 1x minus 2. Now we're going to start trying to line things up, okay? X cubed. Now, that's a difference of squares as well, and that becomes x minus 2, x plus 2 times x minus 1 times x plus 1. Okay, divided by x plus 1 times x minus 2. The x cubed, we can go and put it in the front, so that's x cubed. And then we know that x squared minus 1x minus 2 factors to become x minus 2x plus 1. All right, so now, and I know this works probably a little confusing to see, so let me just kind of draw lines here. So this is work, this is work, and so now here we have a new line of work. Okay, now we're gonna rearrange all of this so that we have it lined up and we can divide things out. Well, x cubed, we have that. And then I'm just going to rewrite the numerator, x minus 2, x plus 2, x minus 1, x plus 1. All right, so we've already gotten, and I mark things out as I'm putting it down so I can focus better on what I need to write. Okay, so now I'm looking for an x minus 2. I have 1, so there's x minus 2. Mark that out, grab that. Now I'm looking for an x plus 2. There is no x plus 2. I'm looking for x minus 1. There's no x minus 1. And here we have an x plus 1. So x plus 1. Okay. And then really we're just going to fill this in because we can't do anything with it. X plus 1, x minus 2. Okay. So now we know that this becomes 1. This becomes 1. That becomes 1. We're left with this. So that equals x plus 2 times x minus 1 divided by x plus 1 times x minus 2. I'm hoping that as you see working example 7 that you're starting to see that organization and being as neat as possible helps when working mathematical problems, especially like this, because if you weren't neat and organized, it would be very hard to keep track of all the steps and all the different things that were dividing and becoming one. All right, so now let's move on to example 8. All right, when you divide by fractions, you flip and multiply. So then that's 20 divided by x minus 1 times 3x minus 3 divided by 6. Okay, so again, we want to factor what we can, so that's 20 times 3x minus 1 divided by, and see, at this point you want to put the order, instead of putting x minus 1 times 6, you want to put 6 times x minus 1. All right, so then at this point, 3 divided by 6 becomes 1/2. So that's 20. Well, this becomes 1, so 20 divided by 2, which equals 10. All right, last example. Example 9. All right. All right. So here again, you flip and multiply. So that's 2 divided by x plus x divided by 4 times x divided by x plus 1. Now at this point, we need to add these by finding the common denominator. The common denominator is x times 4, which is 4x. So we need now to multiply 2 divided by x times 4 divided by 4, plus we need to multiply x divided by 4 times x divided by x. We're not going to do anything with the x divided by x plus 1 yet. Okay, so now 2 times 4 is 8, plus, let's see, or divided by 4x, plus x times x is x squared, divided by 4x. Now we can add these because they have the same denominator, times x divided by x plus 1. So now that becomes, we put the x squared first, so x squared plus 8. Since they're both divided by 4x, we can put it divided by 4x times x times x plus 1. And I know you want to multiply the x times the x squared plus 8, but watch if you don't. So now, if I just say that's x times x squared plus 8 divided by 4x times x plus 1, you can see that the x's divide and become 1, and then this becomes x squared plus 8 divided by x plus 1. All right, so at this point, if you understood the examples, go and start working on an assignment. If you had some trouble and kind of got a little frustrated on this and you're like, I really don't understand some of this, come to class. I'll go over start going over the assignment, and I can always go back and do the examples again in class. And so you can ask questions as we work through them. So with that, have a wonderful Wildcat day.